Dr. Lakmal.
Thank you, Madam Chair, and welcome you all to the KDU for the symposium and fourth and final technical session of innovative modeling. So, as our Chair Madam explained, this is somewhat mathematical based and also much more text than when comparing to the last session. So I don't know, it might be somewhat boring for technical and mathematical sections. So however that, the spatio-temporal process approach for multi-hazard risk analysis. So as the outlines, introduction, the objectives of work, and the current status of risk analysis, limitations, solutions, as well as analysis of the solution and conclusion is include this presentation. So as the introduction of multi-hazard risk analysis, hazard, as you all know, it's a natural as well as man. So whatever that the situation, so normally we are considering the natural hazards, so if it is a natural phenomena. So however that the natural hazard, even though it's a man-made or a natural, whatever that, the risk analysis is the main aspect of the qualitative and quantitative assessment of the innocent human life. So when considering the risk analysis, we have to face, we have to answer this kind of questions. So the ultimate outcome of these questions is the relevancy or the value of risk analysis to the life, because it's always, hazard is always a trouble or a problem or effect to the innocent human life, as I explained. Right? So the objective of this is, research is to develop a mathematical approach to overcome the uncertainties of risk analysis. So under that one, there are two scopes: the peculiarities, determination, and so accommodate peculiarities combining space as well as temporal information. So this is a couple of space as well as temporal information. So the current stage of risk analysis, basically risk depends on two factors, that is probability risk as well as its effect of the event. So effect basically depends on the characteristics of hazard and its exposure and vulnerability to the people and built environment. So basically those effects can be classified in building and built-in environment, direct and indirect economic loss, as well as socialist losses. So as you all know, when we are representing function or a model or phenomena, whatever that, we need representation. Those basic representations are basically generated from mathematics. So that's why we call as mathematical models. And when we are representing mathematical models, we face two kind of mathematical models, that is deterministic and probabilistic. Deterministic model is a somewhat straightforward modeling system. It's for a specific scenario, it gives the results of a specific scenario, but unfortunately it is not much concerning about their uncertainties. But on the other hand, probabilistic models concern all those uncertainties. So it actually it gives the real picture of the risk. So when concerning to the uncertainties, why we need these uncertainties? Because it is the core of the situation. So basically there are two uncertainties. One is called epimistic uncertainties and second one is called aleatory uncertainties. Epimistic uncertainties is just a simple situation. Actually it cannot be as simple situation, but however that we can say it's somewhat inadequate data or insufficient data or incompleteness of the model that euphemistic uncertainty can be generated. So we can overcome this euphemistic uncertainty by using ample of data or generating a complete model. But on the other hand, the aleatory uncertainty, that is not somewhat the lackness of data or incompleteness of the model, but it's the variability of inheritance, randomness of complex physical phenomena. So due to that uncertainty, the basic example for the uncertainty is we cannot predict where, when, where, or in which intensity the next hazard will happen or which occur. So why we cannot predict? Because those are the because of the barriers what we have presently concerning in our mathematical modeling. So what is the modeling is, first barrier is the time dependent data. We don't have time dependent spatial data. Basically we all concerning spatial data but not time dependent, right? Then the second one is dynamism based analysis. So the solution to the limitations, so under that one what we suggest is spatio-temporal data, means the fourth dimensional data. So it can consist x, y, z as well as t, but in here keep in mind that this time is not an dependent variable in this kind of situation. It means we cannot assume time with respect to the location. So it's a time independent data. So time is the independent variable. It means at this time what will be the location. So spatio-temporal processes also, the when considering dynamism, we need it should be definitely it should be a dynamic system. So it's a process-based analysis, and in this case also time is the vital factor, and under that one we concern process, events and actions. So this process basically can be automated by the concepts of mathematical concepts of phi calculus, which was introduced by Robin Milner in 1994. So in my research I have added another extension called space-time extension or ST phi calculus to represent the spatio-temporal connection to the calculus model. So this is the basic syntax of spatio-temporal calculus model to represent a process. So at the first section it represents the process with phi derivatives, and P1, P2 represent the parallel processes. This third part, it represents the limitations or the restrictions, and 0 is the inert process. So this is the basic semantics of ST phi calculus. First one, it represents how the reaction which can be happen when the concurrent processes are going. And the second rule is how the inheritance can be adapted for independent process to dependent process, and how is the basic concept for internal actions. And fourth one, the reaction inside process composition. The rest rule or the restriction represent the reaction of a process with respect to some other spatial or temporal or any kind of other action, and the structure represent the structural congruence of interfering reactions. And finally it has the appending system, appending of two mutually exclusive processes to a single process. So it's at the conclusion level, at the concluding remarks, as you all know, spatial changes can be classified basically static or transitional. So, and on the other hand, temporal changes can be classified as mutation and movements. So, normally we all know mutation is the internal mechanism of this event or a process of interaction between the event. So, normally this is the hardcore or the main concern of risk analysis, and or on the other hand it's the hardcore aleatory uncertainty. So mutation, if we can automate or if we can mathematically model mutation in accurate way, then it's much easier to concern or make a real picture of risk analysis. So semantics of STIFI calculus is the real mathematical representation of mutation. So that's it, the presentation. Thank you very much.
Thank you very much, Dr. Akmal. Dr. Akmal has the master's from Postgraduate Institute of Science, Peradeniya, and he has his doctorate from the School of Geomatics from China. He has plenty of work experience over the years as government surveyor as well, and quite a few publications in international journals. And he has, his research areas are basically on this kind of modeling, location-based services, microwave remote sensing, interesting, and very similar ones in the long run. He has plenty of teaching experience as well, and he's an award holder of several awards. So thank you very much, Lakmal.